This is section 1.8, part B, on solving systems of equations by substitution and elimination. First, we're going to look at the substitution method, and these are the 3 steps that you need to take in order to complete the method. First, solve one of the equations for either x or for y, whichever is easier. Then plug that equation into the opposite equation, simplify, and it will allow you to solve for one of the variables, either x or y. Once you have that one variable in step 3, plug it back into the equation that you solved for in the first case to find the other value of the variable. All right, so in example 1, we can see how this works. First thing I want to do is solve one of the equations for either x or for y, but I can see that the bottom equation is already solved for y equals 4x plus 7. So the first step is done. What I want to do now is plug that into the other equation for y. This is going to look like negative 3x plus 2 times, instead of y, I'm going to put the expression that y is equal to, the 4x plus 7. Then, continuing the first equation, equals 9. Now I distribute, I simplify, and solve for the x variable. So negative 3x plus 2 times 4 is 8x, plus 2 times 7 is 14, equals 9. Combine like terms, negative 3x plus 8x, that's 5x, plus 14 equals 9. Subtract 14 from both sides on our way to solving for x. So this gives me 5x equals 9 minus 14 is negative 5. Then I would divide both sides by 5 to get x. Negative 5 divided by 5 gives me negative 1 for x. Okay, that finishes step 2. I've got one of my variables isolated. Now I'm going to plug the value of that variable in for x in the equation that already had a variable solved for. So to find the y value, I know that y is equal to 4x plus 7, so it's going to be 4 times negative 1 plus 7. So 4 times negative 1 is negative 4, plus 7 is going to give you a y value of 3. Okay, to put this together, your final answer should be the ordered pair, because I know that when I see 2 linear equations, finding the solution is finding the intersection point. So my answer should be the ordered pair, negative 1 for x, comma 3 for y. Okay, let's look at part B. Once again, we're going to identify which equation is the easiest to solve for y or x, whichever variable works out best. It's not already solved for in this case, so I'd look for the smallest coefficient. So I'm going to see that I have a y as a 1 coefficient in the second equation. That's going to be easiest to solve for. So I'm just going to subtract 2x from both sides to get y equals negative 2x plus 5. I like to write my coefficient of x first and then the constant at the end. Okay. Once again, I know what y is equal to, so plug it in for y in the other equation. That's going to give us 2 times the expression for y, so 2 times 2x plus 5 equals 8 minus 4x. And then we're going to simplify and solve for x. 2 times negative 2 is negative 4. X plus 2 times 5 is 10 equals 8 minus 4x. Solve for x, so I'm going to add 4x to both sides. And if I add 4x to both sides, negative 4x plus 4x is 0. So I just have 10 equals 8 plus negative 4x plus 4x is 0. So I just have 10 equals 8. Now, 10 equals 8 is not true, which leads me to the conclusion that this system has no solution. So the answer to this system is going to be no solution. Now, remember that when I graphed 2 lines in part A, I could get no solution if these lines were parallel. So that must be the case here. Since there is no solution, since 10 is not equal to 8, this is not a true equation, these 2 lines must be parallel. So I'm just going to write this, parallel, as a reference. These 2 lines must be parallel. And the other thing that I did in section A was I identified a kind of system. This was the inconsistent type. Now, just to verify, we already know the answer is no solution, but just to verify that these 2 lines are parallel, let's check that when I solve for y in both equations, I get the exact same slope. So I've already got the bottom equation solved for y. If I take the top equation, 2y equals 8 minus 4x, if I solve for y by dividing by 2, that would give me y equals 8 divided by 2 is 4, minus 4x divided by 2 is 2x. Just reorder it to put it in slope-intercept form, so negative 2x plus 4. You can see that the slope is -2 in both of your lines. So once again, just confirming that these two lines are parallel. And therefore, it should make sense that the answer is no solution. Okay. All right, let's look at the next page, find part C. I'm going to use substitution again in part C, and I want to look for which variable is the most convenient variable to isolate. So look at coefficients 2x, y, 5x, 3y. So since this first y has coefficient 1, that's going to be the most convenient variable to isolate. So I'm going to start by solving for that variable. So 2x plus y equals 10. I want to solve for y, so I'm going to subtract 2x from both sides. So going to give me y equals -2x plus 10. Again, I like to write that slope value first. Now that I know what y is equal to, I'm going to plug that into the other equation for y. So it's going to go into 5x plus 3 times y, so 3 times that expression, -2x plus 10, equals 3. Okay. Distribute and solve. So we've got 5x, 3 times -2 is going to be -6x, and 3 times 10 is plus 30, equals 3. Combine like terms, you've got 5x minus 6x is -1x, or just -x, plus 30 equals 3. You're going to want to subtract 30 from both sides. -30, -30. Then you're going to have -x equals 3 minus 30 is -27. And if you divide both sides by -1, you get x equals positive 27. Okay. Now, I want to plug that x value in to the equation that I solved for y, so I can just replace the x value now with my 27, and I will get the y value. So my y is going to be equal to -2 times 27 plus 10. So y equals -54 plus 10, or y equals -44. So the solution to this system should be the ordered pair 27, -44. Okay. So 2 notes about this one real quick. First of all, because the ordered pair is so large, 27, -44, this is one that I would not have been able to solve on a regular graph. So it's a good thing that I was able to solve this one algebraically. And the second note is that whenever I get an answer so large like this, I want to just check it just to make sure it's true. So why don't you go ahead and check this one. So I'm getting my calculator ready. And to check, I just want to plug in the equation 2 times the x value, so 2 times 27, plus the y value, which is -44. Just see, it's equal to 10. It is, so the first equation checks. You have to check both equations to make sure that it's true. So I need 5 times 27 plus 3 times -44. It is also equal to 3, so if you check both equations and they both are true, it confirms that you have found the correct ordered pair. So it's just helpful to know how to check to see that an ordered pair is correct, especially when you have such a large value for your answer. The last one, part D, I'm going to try to find the variable that's easiest to solve for. So I look at the coefficients of x and y. I have -1, 3, 2, and 6. So I'm going to choose the -1. And what I'm actually going to want to do is solve for x on this one. I can solve for x because its coefficient is smallest, it's closest to 1. So on that first equation, we have -x plus 3y equals 4. The first thing to do, I'm trying to get x by itself. It's x this time that I'm going to solve for. So I'm going to subtract 3y from both sides. That gives me -x equals -3y plus 4. And then because I have -x instead of x, I'm going to divide both sides by -1. -3 divided by -1 would be positive 3y, and positive 4 divided by -1 is going to be -4. We like to choose the smallest coefficient because if I can divide by 1, I won't get a fraction, but if I had to divide by 3 or 2 or 6, then I could get fractions in my equation, which are going to, not make it impossible, but complicate the process because I'm going to have to deal with a lot of fractional numbers. This time, I know what x is equal to, so I'm going to plug this expression in for x in the second equation. So I start with 2 times the expression 3y minus 4 in place of x, minus 6y equals -8. We're going to simplify this expression and we're going to solve for our y value first this time. 2 times 3 is 6y, minus 2 times 4 is 8, minus 6y equals negative 8. Combine like terms, negative 6y minus 6y is 0, and I have negative 8 equals negative 8. This is similar to what happened in part B, except that these are actually equal this time, so these are true. So since they are true, what we have here is the identity case. And instead of these lines being parallel, these lines must be exactly the same. So my conclusion is going to be that the solution is all points on the line, and just list the one that you have solved for y. So all points on the line, y equal, oh, I don't have any solved for y. I can use the one I have solved for x, but I really should solve for y. I'm going to do that real quick and then verify that they are the same. Okay, so over here, negative x plus 3y equals 4. If I solve for y instead, I would have to add x. So it would be 3y equals x plus 4, and I would need to then divide by 3 to get y by itself. So y equals, that's 1x divided by 3, which is 1/3 x, plus 4 divided by 3, which is 4/3. I'm hoping my answer is going to be y equals 1/3 x plus 4/3. But to really confirm and check that, we're going to solve the other equation for y and verify that we get the exact same thing. So this equation was 2x minus 6y equals negative 8. I would start by subtracting 2x from both sides, giving me negative 6y equals negative 2x minus 8, then dividing both sides by negative 6. So y equals, the fraction negative 2 over negative 6 would reduce to 1/3, positive 1/3, and then the negative 8 over negative 6, if you divide them both by 2, would reduce to the fraction 4/3. So you can see that you do get exactly the same equation if you do solve for y. So all points on that line are going to be solutions. And again, the case is identity for this one. Okay. On the back of this page, we're going to get into our second technique, the elimination technique. And the elimination technique is particularly good when you can't solve one of the equations for a single variable. Now, in part A, this equation could be solved by either substitution or elimination. We're going to do it by elimination. But for B example, there is no variable that's easily solved for without creating a bunch of fractions. So elimination is going to be really the best technique here. Okay? So the first step would be to choose a variable to eliminate by identifying the lowest least common multiple, the lowest common multiple of the coefficients. Then you're going to multiply each equation by whatever it takes to create the least common multiple, add the two equations, which will allow you to solve for one of the variables, and once you have your first variable solved for, you plug it into the equation to find the next. So for example, if I wanted to find the lowest common multiple, I'm just going to first of all list the least common multiple for my x's and for my y's, and then I'm going to select. So the least common multiple is the smallest number that both coefficients will divide into. So 3 and 4, the least common multiple has to be 12 because that's the smallest number that both 3 and 4 divide into. Okay. For y, 2 and 1, the least common multiple is 2. It's the smallest number that both divide into. So we're going to choose the lowest value because it's going to create the smallest coefficients. The numbers are going to be smaller and easier to work with. So I'm going to get rid of y's first in this case. Okay. Now I need to figure out what I need to do to multiply each equation by in order to create 2's. Now keep in mind, I want to create opposite least common multiples, which means I want one equation to have a positive 2 and one equation to have a negative 2 so that they eliminate, hence the name elimination, when I add the equations. The top equation already has a negative 2, so no change. I'm going to multiply the bottom equation by 2 so that they are the same number but opposite. The top equation is going to stay, 3x minus 2y equals 8. The bottom equation is going to become, distribute this through, 2 times 4 is 8x, plus 2 times y is 2y, equals 2 times 7 is 14. Make sure that you don't forget to distribute to both sides of the equation. All parts of the equation get multiplied by that 2. So the goal being that when I add the two equations together, one of the variables eliminates. Starting with the x's, I've got 3x plus 8x is 11x. And the y's, negative 2y plus positive 2y, eliminate, adding to 0, then equals 8 plus 14, which is 22. Now I should be able to solve for x by just dividing by 11, giving me x equals 22 divided by 11 is 2. Now that I have one of the variables, I have the x variable, I'm just going to take that x value and plug it into either of the equations, it doesn't matter whichever one looks best today, and solve for y. I'm going to plug it into the bottom equation. 4 times 2 plus y equals 7. If I plug 2 in for x, gives me 8 plus y equals 7. And if I subtract 8 from both sides, I'll get the y value is negative 1. So this ordered pair solution should be 2, negative 1. All right, we're going to look at part B, and we're going to use the elimination process again. To start off, I just want to list the least common multiple for the x's and the y's. For the x's, looking at a GCF, or a least common multiple of, let's see, 6, 2 and 3 both go into 6, and for the y's, 4 and 5 both go into 20. Okay, we tend to try to choose the smaller one. You could get rid of either variable, but if you use the smaller one, your numbers stay smaller overall, so you don't have to worry about using your calculator to do most of these additions, subtractions, etc. Okay. Now, since neither of those values is 6, I'm going to have to multiply both equations by a value. 3, I can multiply this top equation all by 2. That's going to create a positive 6 in x. So I know that I need one positive 6 and one negative 6. So the bottom equation is going to need to be multiplied by negative 3. Okay, so if I finish that multiplication, 2 times 3 is 6x, 2 times 4y is 8y, equals 2 times 9 is 18. That's what I have for my top equation. My bottom equation is going to have negative 3 times 2x is negative 6x, negative 3 times 5 is negative 15y, and negative 3 times 13 is negative 39. Add up your two equations. 6x and negative 6x eliminate. They add to 0x. And then you have 8y minus 15y, which adds to negative 7y. And negative 18 minus 39, which adds to negative 21. Now you can solve for y by dividing both sides by negative 7, and you come up with a y value of 3. To find the x value, take your y value of 3 and plug it into either of your equations for y. I'll use the top equation this time. So this gives me 3 times x plus 4 times the y value, which is 3, equals 9. So that's 3 times x plus 12 equals 9. And I know that I can subtract 12 from both sides to get 3x equals negative 3, and then dividing both sides by 3 will give me x equals negative 1. So the solution to this system is going to be negative 1, 3. Okay, let's look at the next page. 2 more examples of elimination. First thing I want to do is consider what the least common multiples for x and for y are here. So for the x's and the y's, the x's, 4 and 6, they both go into 12. 3 and 5 go into 15. They're really so close it doesn't matter which one you use to get rid of your variable. I'm going to go ahead and use the x's because it's a little bit smaller. So to make the top equation have a coefficient of 12 for x, 4 is the coefficient currently, so I need to multiply by 3. That would give me a positive 12. Bottom equation has a 6, so you need to multiply by 2. It needs to be a negative 2 to make that 12 negative. You need to have one positive and one negative coefficient. Okay. 3 times 4 is 12x, minus 3 times 3 is 9y, equals 3 times 10 is 30. That's the top equation. The bottom equation, negative 2 times 6 is negative 12x, negative negative multiplied to positive 10y, negative 2 times 8 is going to be negative 16. If you add up the x's, 12 plus negative 12 is 0x, negative 9y plus 10y is y, and negative 30 minus 16 is 14. So I have a y value of 14. Plug that into either of my equations. Let's use the top one for example. We've got 4x minus 3 times 14 equals 10. So 4x minus 3 times 14 is, let's see, 42. 42. Then I need to add the 42 to both sides. So 4x equals 52. And I want to divide both sides by 4. So x equals 52 divided by 4, which is 13. So my answer is going to be 13, 14. This is another example of the fact that I've got a large ordered pair right here. This is one that I wouldn't be able to have done by graphing. Even though I could graph both lines, I wouldn't be able to see the intersection on the graph. One more of this type. What we have next has, let's see, 5 and 10 for x. So the x least common multiple would be 10. And 2 and 4 for y. So the least common multiple on y is going to be 2. So this time, let's go ahead and get rid of y since it has a smaller least common multiple. 4, sorry, it's not 2, it's 4, right? 2 and 4 both go into 4, but still, that one has smallest. Okay, so we're going to make them both 4. The top equation, if I multiply everything by a 2, it's going to have negative 4 as its coefficient of y. And the bottom equation already has positive 4, so I don't need to make any change for the bottom equation. 2 times 5x is 10x. 2 times negative 2 is negative 4y. Equals 2 times 12 is 24. The bottom equation, no change, so negative 10x plus 4y equals 7. When you add up the x's, 10x minus 10x is 0. Negative 4y plus 4y is 0. So you have 0 on the entire left-hand side of the equation equals 24 plus 7, which is 31. Okay, be careful that when both x's and y's eliminate that you write down the 0 for that side, not a letter like x or y. 0 is equal to 31, that's okay. That is our special case. Remember that if you have a non-true statement, that means that there is no solution. Because, and the reason for this is that those two lines must have been parallel, and you could check it on your own if you would like by comparing their slopes. So we'll just make a note on the bottom. These lines must be parallel. Oops. Okay, that must be, sorry, my note didn't show at first. These lines must be parallel, and that is the reason that I got no solution for the answer. Okay, flip the page. All right, this next system contains a bunch of fractions, and we've been avoiding fractions as much as possible while solving these systems. And the good news is we're first going to be able to clear the fractions by multiplying each side by the least common denominator and still be able to solve this without working with fractions throughout the problem. Our answer might still come out with a fraction, but while I'm doing the intermediate steps, I should have whole numbers in these. So looking at each equation separately, I want to know what the common denominator for this equation is. So the first equation has the fractions 1/2 and 3/4, so the common denominator is going to be 4. The bottom equation has the fractions 2/3 and 1/3, so the common denominator is going to be 3. So let's go ahead and multiply everything on the top equation by 4. 4 times 1/2, or half of 4 is 2, minus 2x, I meant to say. That was the x term. Half of 4 is 2x, and then negative 3/4 times 4. 4 goes into 4 once, so you're going to have 1 times 3 is 3. Y equals, so don't forget to do the negative 4 times 4 also, so negative 16. Bottom equation, I'm going to multiply by 3. 3 goes into 3 once, so 1 times 2 is 2x. 3 goes into 3 once, so 1 times 1 is 1y, so minus 1y. And 3 times 4 is negative 12. Okay. So we are going to solve this system now, and just to refresh the two methods, I can solve it by either substitution or elimination. Just to be extra fancy and to really refresh those, let's just do it two different ways. Let's solve it using the substitution method, and let's solve it again using the elimination. So if I use the substitution method, I would look for which variable is the easiest one to solve for. So I'm going to notice that with my coefficients 2, 3, 2, and 1, the coefficient 1 on y is the easiest one to solve for. So I'm going to take my 2x minus y equals negative 12, and we're going to solve it for y. Okay, so 2x, oops, I want to subtract 2x from both sides to get the y by itself. So negative y equals negative 2x minus 12, and then divide both sides by negative 1. So y equals 2 divided by negative 2 divided by negative 1 is positive 2x, and negative 12 divided by negative 1 is plus 12. Okay. Now, continuing the substitution method, I want to plug this expression in for y into the other equation. So my other equation had 2x minus 3y, and I'm going to replace y with the expression 2x plus 12 equals negative 16. Simplify, solve for x. So 2x, 3 times 2 is 6, so minus 6x. 3 times 12 is minus 36, equals negative 16. Combine like terms. 2x minus 6x is negative 4x. Minus 36 equals negative 16. Okay. Let's continue. We're going to add 36 to both sides. Negative 4x is equal to 20. Negative 16 plus 36 is 20. Then you're going to divide both sides by negative 4. So that gives us x equals negative 5. Remember that once you have one value, the x value, plug it back into the equation that you solved for y to find the y value. So y is 2 times negative 5 plus 12. So that is negative 10 plus 12. So I get 2 for y. So my solution is negative 5, 2. I want to solve the same equation, get the same answer, just using the elimination method. Once again, just to compare the two methods. And this was a good question to use either method on because I could solve one of the variables. Okay? If I'm going to use elimination, what I would do is look for a smallest GCF. And so for the x's, it's going to be 2 since they both go into 2. For the y's, it's going to be 3 since 3 and 1 both go into 3. Again, they're super, super close. It doesn't matter which one you choose. I'm going to choose x's because it's slightly smaller. So I want to make both equations have a coefficient of 2. The top one already has a coefficient of 2. Perfect. That means that the bottom one needs to have a coefficient of negative 2 so that they're opposites. So I'm just going to take the bottom equation and multiply it by just a negative. Top equation is going to stay 2x minus 3y equals negative 16. The bottom equation is going to become negative 2x plus y equals 12. That way, distribute that negative all the way through. That way, the x's are going to eliminate when I add them. 2x and negative 2x add to 0, and I've got negative 3y plus y is negative 2y. And negative 16 plus 12 is negative 4. Then I can divide both sides by negative 2 to get y equals 2. After I get y equals 2, I want to plug that into either of my equations and find the x value. Let's go ahead and use the top one. So it's going to be 2x minus 3 times the y value is 2 equals negative 16. So that's 2x minus 6 equals negative 16. I would need to add 6 to both sides. To get that x by itself, I've got 2x equals negative 10. And that gives me, if I divide by 2, x equals negative 5. So my solution is negative 5.